To understand how to introduce hybrid cryptography, it is important to know more in depth how digital certificates are used and how they are populated. In particular, which important fields are present in a digital certificate, which fields contain the public key and the signature. The goal of this lecture is to present mechanisms to combine hybrid quantum-safe cryptography with digital certificates. There are a few approaches of achieving hybrid, and all of them come with pros and cons. This lecture's aim is not to advocate for one type of certificate over another, but to show how hybrid certificates can be implemented and to discuss the practical implications of adopting a specific type of hybrid certificate. There are two approaches. The first one consists in using a double PKI with two separate certificates. The second one consists of integrating a single hybrid certificate containing two public keys and two signatures in a conventional PKI. Hybrid certificates come in three different forms: catalyst certificates, Camino certificates, and composite certificates. The most naive approach is to use two separate certificates, matching two public keys with the identity of the subject, one certificate using quantum vulnerable cryptography, while the other one using quantum safe cryptography. Double certificates can potentially achieve either hybrid AND, also known as hybrid both, or hybrid OR. The choice depends on how you manage the verification process. You would have to instruct your environment to handle the verification of two different certificates. Having two certificates also comes with the issues of managing two certificates. How you are going to manage the different keys and signatures from both a technical point of view and a policy point of view. How do you enforce that both certificates are verified correctly? Is the lifetime of the certificates the same? If one certificate is revoked, what happens to the other one? So, for simplicity, it is more convenient to use only one hybrid certificate, a single certificate that contains two public keys, both signed by the CA. Let's look at examples of the three types of hybrid certificates. Let us start with the catalyst certificate. First proposed as an IETF draft and expired in 2019, it is now integrated in the ITU-T X509 standard and is available in the cryptographic library Bouncy Castle. The core idea of catalyst certificates is to introduce three additional fields, namely alt signature value, alt signature algorithm, and subject alt public key info, which are the counterparts of the three standard fields that we have considered earlier. These fields are populated with alternative public keys and signatures, which in our case will be the quantum-safe public keys and signatures. The three additional fields are included in the extension field of the digital certificates. They can be flagged either critical or non-critical, but the standard recommends setting them as non-critical. In fact, setting them as critical would require the party in charge of verifying the certificate to be able to understand them and use them correctly. Introducing the quantum-safe public key and signature in the extensions aids backward compatibility, because parties that are not able to parse the new fields can still operate correctly as they can just ignore them. For this reason, catalyst certificates capture the hybrid OR paradigm. You can always enforce your own policy of setting the extension fields as critical. In this case, you are forcing the fields to be checked. By enforcing this, you are making the certificates non-backwards compatible, but you can achieve the hybrid AND paradigm. However, catalyst certificate has a significant drawback. Verifying both signatures is not a plug-and-play solution. Most of the software performing the verification is not instructed to manage two keys per certificate and even perform two verification. For this to happen, the entire verification process needs to adapt. The Chameleon certificates were designed to fix the shortcomings of the Catalyst certificates, including the adaptation to the verification process. Chameleon certificates are still an EITF internet draft, so they are not a complete standard, but already supported in Bouncy Castle. While Catalyst certificate introduces three extra fields with the extra public key and signature information to be handled by the verifier, Chameleon certificates introduce only one extra field called Delta Certificate Descriptor, which is also located in the certificate extensions. The Delta Certificate Descriptor contains information to reconstruct a new certificate called Delta Certificate. When the verifying party tries to perform verification, the Delta Certificate Descriptor can be used to create a digital certificate containing only the quantum-safe public key and signature. This time the verifier just needs to handle the Delta certificate, which is like any standard certificate. The Chameleon certificate inherits the backwards compatibility from Catalyst certificates and aids in the management of parsing a hybrid certificate. The last type of hybrid certificate is called composite certificate. Composite certificates are still an EITF internet draft, but are being adopted by a few cryptographic libraries like Bouncy Castle and OQS. Composite certificates were created with a focus on security rather than backwards compatibility. Let's see how they achieve it. In composite certificates, the three fields of subject public key info, signature algorithm, and signature value are now adapted to accommodate the use of multiple public keys and signatures, rather than adding extra ones. The fields are populated differently. Now, an OID is assigned to every hybrid combination of quantum vulnerable and quantum safe algorithms. The way that these certificates are constructed is by creating a sequence of quantum vulnerable and quantum safe algorithms, and both signatures are verified at the same time. So, even if ECDSA with curve P256 has its OID and MLDSA has its own OID, the hybrid use of ECDSA with MLDSA will have yet another OID. Hence, the signature algorithm field will report the OID of the two combined signature algorithms. The signature value field will contain the two signatures, and subject public key info will report the OID of the combination of the public keys and their relative information, presented in sequence. There is still no convention of the order in the certificates. Adopting first a quantum vulnerable and then a quantum safe algorithm will not have the same OID of the same algorithms in inverted order. Please note that the adoption of new OIDs and new field structure makes it impossible for non-updated verifiers to correctly parse the composite certificate. Since the verification of both signatures is enforced, composite certificates provide hybrid hand security at the cost of backwards compatibility. Additionally, public keys and the signatures management becomes simpler. If a verifier can parse and support composite certificates, the verification can be performed more straightforwardly by the cryptographic functionalities that support your application. While this is not entirely effortless, it is simpler compared to the Catalyst certificates. To recap what we have discussed in this lecture, planning to use a naive approach and opting for a double PKI and handling two certificates comes with a lot of certificate management issues. Therefore, it is desirable to use a single certificate that contains both quantum vulnerable and quantum safe cryptography. These certificates are called hybrid. Hybrid certificates come in different forms: Catalyst, Chameleon, and Composite.